All right, so this is going to be video 3 of our 3B section. All right, so in this next box, I'm going to change some words. Sometimes it works to write a statement joined by and as a three-part inequality, as in this case where I have my 0 and my 3. I have x is less than 3, x is greater than 0, and because it's the word and, remember, when we do an and, we want the numbers that are in both the first one and the second one both, which ends up being the ones that go from here to here in this case. And when we describe it, we can describe it then, you can see the and numbers, if these represent the x's, we can say that 0 is smaller than the x's and x is smaller than 3. So you can see it actually represents x is greater than 0, which says right here, and it also, and x is less than 3. So when you write it like this, it is an and statement, but not all and statements can be written this way, just the ones that take a look like this, not all of them. All right, so but say we do have an and statement that is written as a three-part inequality, then what we're going to do to solve it, really what our goal is, so the goal is to get an x in the middle. So here I'm going to say goal to end with just x in the middle. All right, so here we go. So to get just an x in the middle, I would need to first add 1. And when I add, you can see we kind of, the inequalities have this divided into 3 parts. So I'm going to add 1 to all 3 parts. And that's going to give me a negative 6 is less than or equal to, now it's 3x is less than 12. And then I'm going to end, because I want an x in the middle, I'm going to divide everything by 3. And that's going to give me a negative 2 is less than or equal to x is less than 4. And if I had to draw it on a number line, I'd have a negative 2 and a 4, colored dot on 2, open dot on 4, and everything in between. All right. We're now going to move back and to the very last problem, example 5, and look at something that is a little bit harder. All right, so here this looks very much like that last problem that we just did. You can see we've got a three-part inequality. But if I were to, I could add 5 to everything, but if I were to divide everything by 3, you notice I've got x's in these other 2 spots. I can't eliminate the x's here, and I want just a single x in the middle here with no x's on either side. I need numbers over there. So when I have a situation like this, it is going to only work if we split it into actually 2 separate inequalities with the word and in the middle. So I'm going to say 2x minus 7 is less than 3x minus 5. So that's this left part right here. And the 3x minus 5 is also less than x plus 11. So kind of separate out the 2 inequalities and write one on the left and one on the right. Then solve it. So let's subtract the 2x from both sides. And that's going to give me negative 7 is less than x minus 5. Add the 5. And we get that negative 2 is less than x. And I'm going to switch that around and say that x is greater than negative 2. Now let's do the same thing over here. Subtract x. And that'll give us 2x minus 5 is less than 11. Then add 5. And get that 2x is less than 16. Divide by 2. And we get that x is less than 8. And again, we've got this word and here. So we want to do this and that. So to do that, we can't put it back together because remember I said not all and statements are three-part inequalities. So what we're going to do then is we're going to draw our three number lines, and on it we're going to put the -2 for the small number and the 8 for the larger number. And we got x is greater than -2, looks like this. X is less than 8. Okay, this one did work out that way. And we end up with, then when I do an and statement, this, and then everything in between. So when I write it, I have -2 is less than x is less than 8. So it did end up looking like this, but it does not always do that, I promise.